for chapter 7. And I'm going to look at different topics within chapter 7, because this is a review for the final. You know that the final has a lot less questions. It's still, God, does it take me forever in a day. I probably won't be finished even writing the final until Sunday. And it is getting bigger as I go through the sections. Towards the end, especially, the last sections have a lot more things you can ask. Right, a lot of different things you can ask. So it's ending up that they're generating more questions. So I think last time I said 15, it's probably more likely 20 based on the way I'm going. So let's look at the first group of questions. The first topic within chapter 7 is what are called identities, trig identities. And most of the types of questions that you're going to get are going to be in the form simplify something. So you get a fraction like secant squared x minus 1 over cosecant squared, I should say, minus 1 over cosecant. And you can see the answer. You won't obviously see that, but you will. And then you get a second kind of question here where you actually try and do it and you show your work, right? So that's what that one looks like. And then, well, let's just pause there and look at that as our first kind of question. So I'm going to use the ones that are there because that way it's a little bit easier. So the first one is cosecant squared x take away 1 over cosecant squared x, and we're being asked to simplify it. And the second one is we're being asked to prove that cos x plus sin x squared is 1 plus 2 cosine x sin x. Right, so I'm going to switch to that screen now. And I'll add a couple more of my own, I think, to that particular one. Okay, usual question. Have we seen a big white screen with my wedding ring in my hand wiggling, right?
Yeah.
Okay. Let's look at the first one. When you've got a simplification question, life's a lot more difficult because you really don't know what your answer is. You're just trying to make whatever you've got a little bit simpler. Now, there are strategies for how to do this. One of the most common strategies for simplifying a trig expression is to
You cut off.
going to have.
You cut off.
Am I okay now?
Yeah.
Right. So I think it's just got a large number of people. It's hard for the processor. Right. So I'm going to take cosecant, these cosecants, and turn them into 1 over sine. So cosecant squared is 1 over sine squared.
So what is this strategy called? When you cut off, I couldn't hear it.
Oh, I'm sorry, we're having
no,
audio issues. So I'll try again. Your question is, what's this called? This question is simplify an expression.
No, I mean, what is the strategy? You said there were like
the
different
strategy
strategies.
is to turn,
Yeah.
one of the common strategies at least, is to turn everything into sines and cosines.
Okay, thank you.
So I'm taking cosecant and calling it 1 over sine. So cosecant squared is 1 over sine squared. Now I'm putting all brackets for emphasis. We need to figure out how to make this look prettier, right? So I don't like fractions with fractions in them, but I can fix that by multiplying by a special version of 1. Would you agree that sine squared x over sine squared x is 1, right? It's the same guy in the top and the bottom, so it's 1. What's the advantage of that? Well, let's see what happens. Sine squared times 1 over sine squared gets you 1. Sine squared times negative 1 gets you negative sine squared. And 1 over sine squared times a sine squared gets you 1 again, which means you no longer have a fraction. And you should be really pleased with yourself because that has now turned into this. And there's a great temptation, unfortunately, it's not true. There is a great temptation to think you're finished. And sometimes you are, but sometimes you're not. Can 1 minus sine squared be written as something else?
Cosine squared x.
That's the one. Now, this is just the annoyance of computer software. You can't help it. They're not human beings. You will type in 1 minus sine squared and it will say you're wrong. And the reason it will say you're wrong is because it was expecting you to go that extra step. Now, suppose, just for argument's sake, that this question was in the test, the final exam. You'd get all the way to here, and you'd write it in, and you think you'd be happy, and then you move on to the next question. When I look at your test score, because it's automatically graded, it will say 0 out of 10 points, probably. But I will look at your working, and hopefully you will have given me your working, and I will see this line, and I will say, oh, all she or he did was they forgot to recognize that this can become that. Do you see that you've actually got probably 8 out of 10 points here? Because you've done about 80% of it right. Isn't the only thing you've not done is move on. So always think about, very carefully, about writing down your working to any specific question that you've got, because that's going to be a godsend for you to get partial credit. If you don't show me the working, I'm just going to have to accept that it's wrong, and I'm not going to try and second guess someone into what they thought or what they did wrong, at least. So that's finished. We're done. Now, the second question was phrased something like this, and it was saying, prove that this is equal to that. Well, so I'm going to take the left-hand side and make it look like the right-hand side. So in this case, it's going to be cosine x plus sine x all squared. Well, that's the same thing as cosine x plus sine x times another cosine x plus a sine x. And then I'm going to do FOIL. Cosine times cosine we call cos squared x. Cosine times sine, I'm going to call that cos x sine x. Sine times cosine, I'm going to call that sine x cosine x. And sine times sine, I'm going to call that sine squared x. Now, the advantage of this question is you know what you should get. And this is where I am right now. Cos squared plus a cosine sine plus a sine cosine plus a sine squared. Is there anything you can do here to get this tidied up?
Cos squared plus sine squared equals 1.
Agreed? Cos squared plus sine squared? And that's equal to something, isn't it?
1.
1. Now, what about this cosine sine plus this sine cosine? Aren't they really the same thing, just like AB and BA, right? They're the same thing, essentially. So don't you have two of them? Now you're finished. Are we good?
Yeah.
Okay. Now let's just pick something at random, see what I can come up with here. It's hard to come up with an identity just off the top of my head. I should be able to do something. Oops. Okay, I hope that one's going to work. Simplify tan x, take away cosine x, and 1 minus cosine x. So we're going to try and simplify this fella. And Let me change it a little bit. Sine x tan x, take away cosine x over 1 minus cosine x. Let's simplify that. Sine x times sine x over cosine x, take away cosine x, all over 1 minus cosine x. So all I've done here is change a tangent into a sine over cosine. Now, although there is nothing wrong with the bottom, 1 minus cosine x is quite nice. Would you agree that the top is not very pretty? In particular, that cosine x on the bottom here is not very pretty. So you might not need this line, but I'm putting it in anyway. I put my line in the wrong place. There we go. That's where I was meaning to put it. Right. Focus on this guy. Any way of making this fraction prettier?
Multiply by cosine x over cosine x.
Bang on. That's exactly what you do. Now, cosine times this guy gets me sine squared x. Cosine times this guy gets me cos squared x. And I'm now going to pretend that it was plus all the time. And on the bottom, I'm going to have a cosine x and a 1 minus cosine x. So pretend that was always plus. I think you can see why I want it to be plus here. Anything I can do to the top row? Drusilla.
Turn
That
it to
equals-
1.
Beta equals 1. And since this was a made-up question, there's not an awful lot more I could do to that question. Typically, you should try and not have fractions in simplified trig expressions. I could certainly help the cosine, because 1 over cosine could be called secant. But there's no way easily, at least, there's no way easily to fix the next part. So I guess I'm finished.
I have a question.
Yes.
If let's say that the equation said like tan squared x, would you transfer that to being sine squared x over cosine squared x?
You would indeed do exactly that.
Okay, so like it doesn't have to, because I'm looking at the reciprocal identities and it doesn't show like a tan squared x, it just shows tan x. So I just wanted
That's right. So tan x is the only one they show you. You have to adapt that to deal with the tan squareds that you get and things like that. I don't think I've ever seen a tan cubed, but there might be a tan cubed sometime. If there was, it'd be sine cubed over cos cubed probably.
Okay, thank you.
Right. So that's all I really have time for as far as identities go. So let's have a look now at what the second thing that they tend to have. You bear with me for a few moments. Here we are. We have the addition and subtraction questions, and we have questions where you're being asked to find things like the sine of theta plus phi, where you're told some information about theta and about phi. So this is me basically looking at questions like 3, 4, and 5 now. So I'm now going to see if we can attempt versions of those. Right. Start with 3. The key here is they want exact value. We could type into our calculator what the cosine of 41 pi over 12 is. And if we did, we'd probably get, 0.1234. We'd get a decimal. But they want an exact value, and they also say use the addition or subtraction formula. So here's our first problem. It's actually quite a major one with this question. I have to find two numbers, two versions of pi, two fractional versions of pi, that add together, or two fraction versions of pi if you subtract them, you get 41/12. So I'm looking at what on earth that could be, and I'm going through my brain. I'm trying to see what we might have here. What would 2 pi? Say again?
But turn it to like degrees first, so that you can like feel easier to. I don't know. Sorry.
Oh, actually, degrees would work. I mean, it's not a strategy I'm thinking of, but let's show you, because it doesn't mean that it's wrong. It just means it's a different way of approaching it. So if I wanted to do that, I'd have to take this guy. If I want to turn it into degrees, can you remember how you do that? You divide by pi, right?
Yeah.
And then you multiply by something, don't you?
So multiply.
Yes,
Is it 180?
it is.
Okay.
Angle divided by pi times 180. Now, I'm just going to do that because it might make your brain work a little bit better. If you cancel the pi's, it's basically that. So I'm going to do 180 divided by 12. And I get 15. And then 15 times 41. I get 615 degrees. Ah, that explains something. Right, 615 degrees. If you take 360 degrees away from it, you get 615, take away 360 degrees, I get 225, right? So if I take 615 and subtract 360 from it, I get 225. Is 225 in the unit circle?
Yeah, it's 5, 5, or 4.
Right. And isn't 615 the one that we started with? And isn't 360 2 pi? So what I've just found out is that this guy is 2 pi plus 5 pi. So yeah, that worked. You want me to give my thought process? Okay.
No, like I can't see the paper. Like it's
Oh,
or
it's, oh, let me
like
see if I can make it work this way. There we go.
yeah. There.
Right, gotcha.
Well, some of it's still cut off, but that works.
Is it? On
Yeah.
mine, it looks it's working. Oh, I'm not sure how to make that happen. I can't really move my gizmo anymore, and there's a thing here. Okay, I'll show you what the line. I don't know where you're missing, so here goes. You should be able to see that because it's right high up. And I'm taking this and I'm saying it's, if you take away 2 pi from this, you get 5/4 pi. And so that makes this fella 2 pi add 5/4 pi. So we've figured out how to find the cosine of 41/12 pi. We're going to find the cosine of 2 pi plus 5/4 pi. And if I call this A plus B, what we're looking at is the cosine of 2 angles added. Are you able to see this guy here? She's gone. I'm just wondering.
Yeah, I can see it just fine, so I assume everybody else can, unless they're having issues.
Okay, it might be just a screen issue. I'll try and keep away from the bottom line just for everyone's sake. Right, to get the exact value of this fella, don't we have to go and look at one of the many formulas that nobody remembers because there's so many of them? But isn't there one for the cosine of 2 angles being added? And if you
Yeah,
get a really
addition or subtraction one.
I have it if you guys want it. Oh, you guys need it right
there it is.
now.
The cosine of A plus B is cosine A, cosine B, take away sine A, sine B. You can check it up. It might be called alpha or X or whatever, but that's the formula. So the cosine of 41/12 is made up of these two guys added. This is going to be A, this is going to be B, which gives us this. That turns into then the cosine of 2 pi times the cosine of 5/4, take away the sine of 2 pi times the sine of 5/4. And then you go to your unit circle. Does anybody know what the cosine of 2 pi is?
One.
Do you know the cosine of 5/4 pi? Is that fella? And what's the other one? 0 times this guy. So blah, 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 right? I'm just dotting this because I'm looking at the time and these are taking a lot longer than I was hoping. So basically plug in the numbers for the 4 bits, whatever you get, add them all up, combine them, and you are done. Okay. Let's jump to question 5 that you can't see. So I'm just going to tell you what it is. Suppose I give you some information about 2 angles. Suppose I tell you, for instance, actually, let's try this one. Suppose I tell you that the sine of theta, so this is question 7, is equal to -7/25, and I tell you theta is in quadrant 3. And I'm being asked to find the exact value of, let's say, the cosine of 2 theta. There is a formula for the cosine of 2 theta, isn't there? Does anyone know what it is? There's actually 3. Does anybody know any of them?
1 minus 2 sine squared theta.
That's a good one to choose. In this case, 1 take away 2 lots of, that's what sine of theta equals is, squared. That's 1 take away 2 lots of, what's that? 749 over 625. In this case, 625 over 625. Take away 98. I get 527 over 625. And as ugly as that answer looks, it's actually correct. Are we good with that one? Right. Let's suppose I was asked to find the sine of 2 theta instead, right? Which is pretty much, there are only 3 things they tend to ask in this question: sine of 2 theta, cosine of 2 theta, or tangent of 2 theta. But let's suppose they ask for the sine of 2 theta. Does anyone know what the formula for that one is? There's only one to choose from this time.
2
Sine x cosine x.
Right, I think there's 2 of you trying to say that. Yeah. Now, 2 times the sine of x. Everything is fine. And then you hit the oops. They didn't tell me cosine theta. They only told me sine theta. And I need to know this guy, because whatever it is going to go where my finger is. Then I'll multiply everything together and I'm done. So I'm dead close to finishing. So I'm going to create a right angle triangle, which is more typical for these questions. And I'm going to call this angle theta. And I'm going to use the information that they have already given me, which is that. Right now, according to SOHCAHTOA, what are the 2 sides that give you a sine?
Opposite and hypotenuse.
So over here, this is called the opposite, and it's going to be 7. And this is called the hypotenuse, and this is going to be 25. And in a few seconds, I'm going to find the adjacent. How would I find the adjacent? You just tell me how while I'm actually doing it. How would I find the third side of this right angle triangle?
The
Theorem.
theorem.
Yeah. And I'm hoping I'm pressing the right buttons as we speak here. And we got really lucky. It ends up being a nice number.
4.
Yeah, most of the time it's going to be the square root of 18 or something, right? Some semi-ugly like that. Now you notice that that negative had nothing to do with the right angle triangle, because the right angle triangle is physical sides. They are positive direct, numbers, right? But now I know it, I can go back to this formula. And the sine of 2 theta is 2 sine theta cosine theta. 2 times, just like it was before, that fella. Ah,
Does it have to be negative also? Because it's
well done. Cosine of theta, I've just been told it has to be negative. Let's tell you where it came from first. Isn't it the adjacent over the hypotenuse, which is 24 over 25? And then if you're wondering, why was that even told to us? Now it comes in. If you are in the third quadrant, is the cosine positive or negative?
negative.
Right? And you put that guy in. You can now combine everything. And the bottom I can tell you is 625, and two positives make a, two negatives I should say, make a positive. So 7 times 24 times 2, and I get 336. So that's the exact value of the sine of 2 theta. I'm not going to do this one. How would I do the tangent of 2 theta? I mean, that's the third thing they could ask.
Two.
Would you do? Oh, sorry.
No, go for it.
Oh shoot, I feel bad because I feel like I'm controlling everything. 2 tan and then like divided by 1 minus tan squared.
Oh, okay, so you could use, and you're totally correct, you could just use the formula, which means a tangent in this case.
Oh, I see. Okay, I see the other way.
Yeah, but nothing wrong with that. It'll work fine, right? Won't the tangent be 7/24? But in the third quadrant, isn't the tangent positive? So it is just 7/24. And the other way of doing it, which is one you've just noticed, wouldn't you take the sine of 2 theta, which is this guy, and divide it by the cosine of 2 theta, which is this guy? And you could get it that way. And both are equally correct, just depends how your brain works.
Well, that one seems easier.
Whichever you think's easiest is easier. Because not everyone thinks the same things are easy. Some people like one version more than the other, because
I have a
that's,
question on that
yes.
one. So I always messed up with the positives and negatives. So
Right.
in final answer of like sine of 2 theta, it doesn't necessarily have to be negative, because even though it's in the third quadrant.
Well, the reason it doesn't need to be negative, even although it's in the third quadrant, is theta is in the third quadrant, but isn't 2 theta twice as big? And so if you take an angle that's in the third quadrant and you double that number, couldn't it quite easily end up being in the fourth or the fifth? Well, no, you won't get the fifth, but the fourth back to the first or even into the second quadrant. Again, an example. Isn't theta equal
Okay, yeah.
200 in the third quadrant, right? Theta equals 200 is in the third quadrant. But isn't 2 theta 400 degrees? And do you know 400 degrees is in the first quadrant? Because you go all the way around plus 40 more. That makes
Okay,
sense?
thank you. Yeah.
Right. So just because an angle is in the third quadrant, theta is in the third quadrant, that doesn't guarantee that 2 theta is going to be in that same quadrant. It could be in any of the other three. Right, the last version of this type of question is going to be a kind of bigger version of the same idea. Sine of A is 4/5. And angle A is going to be in the first quadrant. Cosine of B is going to be 5/12. No, make it negative 5/12. And angle B is going to be in the second quadrant. And we're being asked to find the exact value of the sine of A plus B. So you got the gist of what this question is about. You've been told what the sine and cosine of A and B are. You've been told what quadrants those angles are in, but you're being asked to find what the exact value of A plus B is. First thing is, you go looking for your formula sheet and you find the sine of A plus B. And it's the sine of A, cosine of B, plus the cosine of A, sine of B. Can you trust me on that? Now, I know this guy. Let's put it in red. I know this guy. This guy is 4/5. Cosine of B. I know this guy. He's negative 5/12. Do I know the cosine of A yet? Nope. Do I know the sine of B yet? Not yet. Those two we have to figure out. And we're going to figure it out by using this information here to find out what the cosine of A is, and using this information here to find out what the sine of B is. So I'm going to start with the sine of A guy. He's 4/5. Just like we did the last time, isn't that going to be opposite over hypotenuse? I'm going to call this here angle A, right? No right angle triangle. Opposite, adjacent, hypotenuse. Opposite is 4. Hypotenuse is 5. Can you just trust me that adjacent is 3 if you do Pythagoras? And what do we know about A? Well, A is in the first quadrant. And I'm going to use this triangle now to find out what the cosine of A is. Well, I know it's the adjacent over the hypotenuse. I know it's 3/5. And lastly, I have to know, is it positive 3/5 or is it negative 3/5? And this guy is the one that tells me. If angle A is in the first quadrant, what will the cosine be, positive or negative?
Positive.
And now we have got this guy who's going to tell me him. So I can now go plus 3/5. Let's go for the second one. The second one is the sine of B. What do I know? I know the cosine of B is negative 5/12. I know that B is in the second quadrant. And I also know that a cosine is an adjacent over a hypotenuse. So I'll build another right angle triangle, put the angle B here, opposite, adjacent, hypotenuse again. The adjacent is 5. This guy here is 12. And this time I'm going to get an ugly square root. And I'm just checking what it is. It's 144, take away 25. It's the square root of 119. I can now use this triangle to find the sine of B. The sine of B is opposite over hypotenuse, which is the square root of 119 over 12. But of course, I still have to find, is it positive or negative? Well, angle B is in the second quadrant. What is the sine of an angle in the second quadrant? Positive or negative?
Positive.
So this is the guy that we use, and he goes in here. This is what we were after, right? We now have all the pieces. There's a couple of quick checks that you can do to make sure you're in the right tracks. Have you noticed that these two guys have a 5 and a 12 on the bottom? And you notice that these two guys also have a 5 and 12 on the bottom? That's not a coincidence in numbers. Whatever these two guys are, these two have the same numbers. So if I think that's 5 and 14, or 5 and 5, or 5 and any other number, I know I'm wrong. Because if this one is 5 and 12, this one needs 5 and 12. That's just the way the mechanics of it work. So you can at least check that out. Now 5 times 12 is 60. You multiply these two together, you get negative 20. and you multiply these two together, and you get a rather unsatisfying square root of 111, 119, I should say. As far as I can tell, looking at that question, there's really not much I can do to make it look pretty. So can we pretend that we did a different question? And this is what we had. And I'm deliberately seeing if I can make this work. Yeah, it's harder to make it work than you think. Suppose it ended up being 20, negative 20 plus 3 square root of 200. Do you know that that can be simplified, and you should always do that if you can? What can the square root of 200 be converted into?
10 square root 2.
Right, so 30 times 10 is 30 square root of 2, so you're correct. Now, do you see that's maybe not a big difference, but it is considered better format. And you know the way the computer is, it is very twitchy, very touchy. So I can imagine you did all the hard work and stopped there when you just had a little bit more to go and it would have worked. But you plug that in as your homework and it says wrong. Do you see how easy it is to be almost perfect and still not get the final correct answer? And so especially when you're doing quite long questions that involve a lot of steps, this one's a great example of that. Try to not be too put off when you get a whole bunch of questions that keep telling you you're wrong. Because your idea, or what I think is going to happen in your brain, is you're going to think, well, I'm just not doing it right. I don't know how to do this question, right? I thought I knew how to do it, but evidently I'm wrong. And you talk yourself out of doing everything that's right. Do you notice that the only thing you did wrong here was you couldn't simplify the square root of 200 because you just never noticed it, right? So watch out for that, because you might well be doing a whole load of revision questions. And I know some people right now have had some issues where you're not sure, you get it wrong, but really you're not sure why, because it looks perfectly correct. And yeah, so that might be what's going on. Question?
Can't you simplify it even further by dividing by 10?
Oh, then I have just screwed up. And I would have got it wrong. You see how easy it is to do the little neat bits at the end? I just made that question up and I just didn't even bother looking. But you look really carefully. Do you see that everybody's got a common factor of 10, so you can divide top and bottom by 10? Now, if I typed that in, they probably would have told me I was wrong. You see this? Now, in the big scheme of things, didn't we do all the clever stuff correct? Wasn't it just tidying up the answer where we might have came a little bit wrong? So when you are doing your final, can you see how vital it is that I see you're working? Because a question like this could be worth 20 points. And if I seen the kind of working that you can see here, then I'm just going to look at that and say, 2 points, that's all you really need. I'm not taking off a whole lot, right? And you'd get 28 points out of 30. Now you think about it, what you've done there is worth 28 points. You haven't even given the wrong answer, you just haven't simplified it perfectly. And I probably take a point off because you wrote that. And of course you get all the points if you got to there. We're kind of rapidly running out of time here. So Monday is going to be just a general review. Bring some topics, bring some homework that didn't work, and that's about all I have to say right now. Is there anybody got some questions for me before we go?
Wasn't like that whole shoot, now I have to forgot. It was the last section. Wasn't that whole section had to do with shoot, never mind. I kind of forgot what it was.
Whenever you figure it out, shoot me an email, I'll try and answer it. I've already got a couple of people's emails, for instance, to do with, I think it was reference angles. And one of them asked you for a reference angle for 5 pi. And the answer is 0, and the other answer for the reference angle for the number 4, and the answer is 4 minus pi. When you're looking for the reference angle, it's the angle something makes with the x-axis. Right? So if you think about 5 pi, it ends up over pointing on the x-axis, so technically it's 0, or pi, but 0 is probably the one they want. And in the second example, the reference angle for 4 radians is the angle that the number 4 makes with the x-axis. So if you take 4 and you subtract pi from it, that's the angle you're looking for.
True. You kind of forgot about Ezra's question.
What was Ezra's question?
It was to like do 17.
Did you have a question to do 17, Ezra?
It was like
I
a
have
long
got-
time. I think it was a long time ago. Way before.
Oh, I don't matter. Let me see if I can get to it. But I do have unfortunately, I do have another class. Is 17 this one here? Are we talking about in the section we've got? Because I may be able to do a very quick version of what the heck's going on. Is this 17 the one you're talking about? Ezra?
Yes.
Okay, here goes. You're going to use your calculator to do this. You're not going to do this algebraically, right?
Help really with the algebraic problem on the bottom.
Oh, is it this? Right?
Yeah.
Oh, you want to do this fella here? Okay. Right. So you're okay with using the calculator to get the decimals. These are the decimal answers, by the way. You put in your calculator sine x minus 1, and you make that the y1, and you put cosine x, and you make that the y2. Agreed? Are we okay with that? I don't have enough time to show you, but if you want to talk to me, we can set up a Zoom meeting and I'll show you. But sine x minus 1, make that y1. Y2, make it cosine x, and you'll have a picture that will look like one of these 4. And then you just find out where they intersect, which is where these numbers are all coming from. Now it says find the intersection of these points algebraically. That I will have to, yeah, unfortunately that's going to skip by, but I'll give you the start of it. Maybe that's enough to get you going.
As an aside, for the test, are we allowed to use sites like Desmos for questions like this?
Yes.
Okay.
Yeah. You're just not allowed to. There'll be a kind of. I will shoot you out an email, but basically the email will tell you what you can and can't do.
Okay, because
Right
this,
off the
yeah.
yeah. Desmos is fine because you're going to actually you could use your TI-84. It would do the same job, so it's not a big deal.
Yeah.
Desmos is just a fancier version of that.
Yeah,
So
it's just
that
a
would
lot
be
easier to type it in that way than just spend a lot of time trying to do parentheses and stuff on the calculator. I
And you can
think
see
I'd
it
save
better,
somebody like
too.
5 minutes.
Right. I have no problems with that. It's
You can see all the
just
points better.
yeah, it's just doing the same technology but doing it in a better way.
Okay,
Right, and
just
if you want to
figured I'd
find it, if you want to find out when this guy here, I'll try to make sure which one I'm clicking on here. If you want to do this guy here, the algebraic way, what you have to do, and I'm going to have to zoom back again, is you're going to have to solve when is, my pen's going, sine x take away 1, when's it going to equal to cosine x? Right, and I'm not even sure this is algebraically, but it is a way of doing it. So if you take this fella here and you rearrange it, it's sine x take away cosine x is equal to 1. So far, so good. Subtracting cosine x from both sides, adding 1 to both sides. Then if you do sine x take away cosine x squared, it's the same as 1 squared. If you multiply this out, and you're going to have to trust me on this, you're going to get that. These two get you 1, so you're going to have this. Subtract 1 from both sides, you're going to get this. Okay, so aren't you looking for places where the sine of x equals 0 and or the cosine of x equals 0? And then plus 2 pi k, because that's what you always add on to things. I know that's like really, really fast, but can you see that's the gist of how you're doing this? And if you watch this video again, you can pause on that page and maybe see what I did in each step a little bit clearer. But,
Oh, basically make it to 0, like solve for 0.
yeah, just solve for 0. So in this case here, aren't you looking for 0 pi, 2 pi, 3 pi, 22 pi? And over here, you're looking for half pies and various other versions of pi that work for that one.